With Open Spatial. Today's webinar is dedicated to exploring ways to get your paper and/or CAD-based data into a GIS environment, creating what we like to call a single source of truth. So I'd like to thank you and congratulate you for taking the time to learn best practices for data management in your industry. I'll introduce our speaker, Colin Hobson, in a moment, but first let me outline the format for this webinar. As Mr. Hobson is speaking, he will be sending some simple poll questions to you. Your answers will help him adapt the presentation to your main areas of interest, so please respond quickly when you see the questions on your screen. Additionally, you may type specific questions in the chat box, and Mr. Hobson will address them as time permits. We may also have time for a brief Q&A at the end. Before we close the webinar, you'll be reminded to schedule a complimentary consultation at gismadesimple.com with me and Mr. Hobson to discuss your specific situation in detail. Many organizations have found Mr. Hobson's suggestions have saved a lot of time, money, and aggravation, so please take advantage of this. Again, the calendar link is gismadesimple.com. Now, there are good and not so good parts about webinars. The good part is that we have folks all across the country gathering together at the same time, and nobody had to jump on an airplane to do it. The not so good part is that comfort and convenience also encourage distraction. We all have the ability right now to click on another page or program on our computers or to get busy doing other things around our offices while this webinar is going on. So our commitment to you is this. We've spent a considerable amount of time putting together what we hope you will find to be a very focused and interesting presentation of effective strategies free of charge. All we ask in return is that you stay with us, stay engaged, because it may be that one of the ideas that Mr. Hobson proposes could end up saving you hundreds of hours and thousands of dollars. And now for our guest speaker. Colin Hobson has been active in the CAD and GIS arena for over 20 years. He worked at Autodesk for 9 years in management in their GIS division prior to becoming the North American director and co-owner of Open Spatial, which is an asset data management and GIS company focused on helping authorities build and maintain accurate infrastructure inventories while making that data more reliable and useful throughout organizations. And now Mr. Colin Hobson.
Hi, welcome to everybody, and we're pleased to present this webinar, and without any further ado, I'll get started. Open Spatial, just a little bit of background. As a company, we are a software and services company, and so we develop our own software and we provide services where needed. And our goal is to make customers successful and work with organizations to build out their asset management solutions. We focus primarily on geospatial engineering solutions, really have a strong background in CAD and GIS, and hence today's webinar as we present this. Our technologies are based on ubiquitous risk-averse platforms, and we've focused on this bridging the gap between CAD and GIS, particularly around the asset management applications. We use open standards and engineering best practices wherever possible. We really deliver a very specific set of solutions working with customers so that it fits their purposes and looking at the long-term investment and savings on that investment. We have essentially 5 products. I'm not really going to focus on the products today, but I will just mention them. Our main product, core technology, is a product called Mansus, which is Managed Utility Network Systems, and it's an editing tool and started out the company, and hence our focus on CAD to GIS stuff. Many people would describe it as a GIS, very powerful product. It's an editing platform for GIS data based on the Autodesk products as the editing user interface, but it actually stores all its data in a single source of truth database. It has off-the-shelf data models and can support multiple users editing data at the same simultaneously off the single source of truth. We have a significant web-based platform called Enlighten, and we refer to this as our geospatial portal and business intelligence integration platform. And this really brings together multiple data sources and goes well beyond what we'll be talking about today, the CAD to GIS piece. The second part, and essentially today I'm going to talk about two things: the editing CAD data and creating GIS data from it, and then also this ACDC product. ACDC is a product that we've been developing over 8 years. It automates the validation and loading of data from electronic submittals of as-built directly into GIS and or CMMS systems. So this is another tool. So without having to edit, you actually can set up templates, validate against those templates, and load that data directly into your GIS, whatever that is, whether that's ours or ESRI or open source or anything like that. You can load directly into that. So ACDC is also a focus of what we'll be doing today. And the word ACDC is derived from from Australia. No, well, actually, yes. It's derived from As Constructed Design Certification. So those are the acronym comes from that. And in Australia, as-builts are typically referred to as constructed designs. We also have browser-based work management applications and various data collectors and applications for mobile users. And for those that are interested, we have a whole infrastructure of products, and for today I'm going to just skip that right now. As a company, we started out in 1994, and I actually was in South Africa at that time but didn't even know about this company. But got to know them as they branched out into North America in 2004. Our head office is in Australia. We have offices in North America and South Africa. If you look at customers, there's a number of counties in California. We have Shell Appalachia as a customer, a number of cities that use our solutions, a lot of utilities and water districts, airports. We also have the Fighting Irish, the Buffaloes, and Trojans and Tritons, so a number of campuses. So it's really quite a diverse set of customers. The focus on all of these is on asset management and utilities, depending on of course, where they're at. But just to give you an idea of sort of the spectrum. The other thing we do, aside from products, is we really help customers build out strategies. This is not something you're supposed to be able to read at this distance, but if you just look at the boxes, they are set up for a certain time period with a stage and a goal and what the business benefit is and what systems it ties together. And so your CAD to GIS is one little piece of this entire puzzle. So as a company, CAD to GIS data is our specialization, and I'll really focus on these two things. We do a number of other things, just so that you know that. We do systems integration, intelligence portals, field solutions, condition assessments, repair prioritization, all of that. But let's take a look at this data conundrum. The data capture, really you can go from scanned record plans or red lines or map books. On the paper side, this is kind of where you'd come from. Or you could have CAD drawings, you could have base maps, so this sort of be the map sheets and various kinds of base maps. Or you could have specific utility system maps or purpose-built maps. Or you could be at the stage where now you have subdivisions and improvement plans coming in and you have a GIS and you're trying to bridge that gap between this CAD stuff and getting it into your GIS. So data can come from virtually anywhere, and I'm going to sort of touch on those sources and then show how you can build that out. Let's start with this CAD piece. So I'll go back to the paper, but just CAD in and of itself. CAD data is interesting. It's just not designed for GIS. It's designed to view and to communicate information. And so when people draw things, they don't always snap stuff. They really may even break lines so that they can put text there so it's readable. Of course, that really makes a problem if you're trying to get a line into your system that's an actual pipe that goes from one point to another and has a length calculated. Or if you're trying to do a modeling network and you have pipes that have no node on the end or junction on the end and they're just incomplete, so you don't know whether that connects or doesn't connect or whether it's just bad data. Or even putting symbols where you break the line work to leave space for where the symbol is and you snap to the edge of it. Now, CAD is a great tool, but you can draw anything you like in any which way you like. The amount of level of structure is one thing, and the other part is the attributes. it's really fairly difficult to get attributes. You can go into blocks, and this here may be text. It could also be an attribute within that block. If it's an attribute in the block, that still doesn't solve the conceptual problem of northeast, south, and southwest, where you kind of sort of have to either go and do some angle calculations and hold that the map is true north, and start working those out. But just reading things like 24-inch chilled water return as opposed to 24-inch chilled water supply, or these invert elevations and rim elevations, and getting all of that loaded, or these ID numbers for various valves and appurtenances. The other thing you may have is this. You may have a whole set of folders, and in the folders you have scans of the actual signed plan. So this is the legal data of record. And so going paper, CAD, how do we get that into GIS? So one of the things we do is we have this product called Mansus, and in there one of the functions, it's a set of menus, and I'm once again not really trying to focus on the product too much, except for you to show you that it really helps a lot with this. But you can take an image and what we call geo-reference it. You'll see this menu specifically says, okay, here's a plan, this will be a TIFF or a PDF. And you can then indicate to geo-reference it 2 points on the plan and 2 points on the map, and then it would be where you see this box is. So if we zoom in on that red circle, you can see now we've geo-referenced that plan such that it's somewhere on the map. And we've done a couple of things. One, it's very useful because now you can do heads-up digitizing, and you can go and edit and update or create new data. And if you're doing that in Mansus, you'd do it right off the menus, so that would be very quick and powerful. The other thing is there's a lot of information on this plan that you might want to use later on for other things, like where was the electric line that came through that they did this, when they surveyed this they went and found it, or the storm drain, or anything that goes on with this. The other thing is that there's the plan itself. What you really want to be able to do is come back later and say, what plans do we have at this street intersection? And so when we capture this, we actually capture metadata with this plan itself. So this little box, we actually put on that there what the file name is, where the folder is. You can enter then attributes of what the project name was, what the year was, and everything. And then you can go anywhere on this map and draw your little box and say query everything into that particular box. So at this stage, let's just check on the audience, and I've just put a little question there. Do you have CAD to GIS? Are you using CAD in your organization? Just giving you time to answer that question if you're using CAD in your organization. All right. I'm going to let it go just a little bit longer. All right, so in the audience, we've got 93% are using CAD in their organizations. I guess that's why you came to this this presentation. All right. All right, I'm going to close that. So 93% of folks are using CAD. While we're there, I'm going to just ask the other question, does your organization also have a GIS? Answer that one while you're there. So let's just get a view of this. And I'll let it go for about 10 more seconds. Okay, so 100% of the audience have GIS and 93% have CAD. So thanks for your feedback on that. All right, let's keep going here. So this really is the question, is getting this CAD data into your GIS. So I'm just going to look at it. I mentioned the Mansus product. This allows you to edit data live and then actually look at it. So let's go and look at this data set quickly. And I'm going to whip through to, so here's some CAD data. you'll see that the thing is, this particular one already, it's been relocated, and you'll see in the title. And if you look at the CAD data, it has exactly those sorts of problems. This one's pretty schematic. And so you'll see it's just a line. It's not broken where something tees off it. The attributes of the line, I can see it's in the layer, but that's about it. The scale, things are large, exaggerated. The text is, the pipe material is not on any of these pipes, and it's very rough. If we locate this against the actual parcel map, you'll see that they're pretty far off in this area. If I go to another data set, here's one. So here's a system-wide CAD drawing. If you zoom right in, you'll see that it's got all of the stuff in there. So this red pipe here is a water main zone 2. I can see that in the layer. So wherever you have like a hydrant, it's not broken. The line just keeps going straight. So common problems that you see there. How do you actually get that to go straight through the valve? How do you get things like the valve number here? This thing is actually 4 separate lines. So obviously someone exploded it. So it looks like a picture. I mean, it's actually on the line there. And its number, this would be the valve number right there, is a piece of text, and it has some line work that goes with it, and a dimension error. So getting that into your GIS is the challenge. It's one of the challenges. In this organization, you can just see that they would not be able to give you length of lines by diameter or material. They would not be able to, say, okay, show me what's the nearest hydrant to this position along the pipe. You wouldn't be able to relate pressure on something, calculating like through a network or anything like that. So big challenge. Even their numbers. So that would be a customer number, and getting that to relate back to which pipes service what customers. Or if the pipe breaks here, who's impacted, kind of difficult. And that's not because CAD is bad, it just wasn't built out. I mean, this drawing was drawn years and years ago, and some of these are directly off paper. So let's go in and just open another one here. And I'll just show you that geoscan quickly. All right, we'll go up a little. Yeah, let's open this drawing. So I'm opening this drawing. As I said, what Mansus does is it connects you to a single central database. And so you need to log in. I'm just logging in on a demo data set. And I may have to do that. So if you go here and you want to get to geolocate a plan, for example, what you can do is this sort of thing. I'll bring over my Explorer here so you can see what I'm doing. But if you have some data, for example, these folders, just pull it so you can see it nicely. But choose one of these. Say you had a plan, one of these TIFF files that was a plan view. So this would be a project, and you'd have, whatever you've got here. So let's take a single page here, look at maybe page 4. And when you use this plan piece in the middle here has actual locations and everything on it. So typically you just take that and put it, insert it somewhere close to where you want to put it, just to get it somewhere on the picture. Don't even worry about the rotation. So there we have a plan, and you can see there's a bunch of information in here, and it runs, there's the section and plan. So using the geoscan tools, you just go to that menu and literally say, let's say this piece here actually goes along this piece of the street. So what I would do is insert the image I did. Let's go in and actually georeference this. and we choose that image, and you'll notice I just get prompted, show 2 points, and I'm going to save time by just showing very quickly. And then pretty much just go in and snap, use all your CAD snaps to 2 points on the map. So let's say that one, and I suppose I said I'd use snaps, so let me turn those on. There we go. And so now it's scaled and referenced this thing. So that's, that just makes that easy. The real value is the next part where we create a boundary automatically and read the data from the image. So I can say, show me this image. And now it's created this green box, which it's automatically pulled out of the of that plan, what the file name is, the path, when it was scanned, and you can now come in and add additional information like the project number, project name, typically the date, anything like that. So this is just editing tools provided in the Mansus product. So you can go in and change edit attributes. And let's go to this particular plan. And let's say typically we put a category. Like this, I think, was a sewer plan. And you can go in and put in whatever the project name is. And post that to the database. Once you posted it to the database, and I won't actually do that now, I'm going to just get rid of it because I just didn't put it in the right place, so we'll move it out of there. Once you've posted it to the database, the next time you want to retrieve anything, you can say, go to an area of the city. Like take here, for example, they were doing ADA ramps here. You can go in and set your area of interest right here for these street corners. And at this point, run a query to say, give me all plans I have that intersect with that. So you're starting to do some GIS stuff. And let's go and say, run this one. And what it's done now, if you look down the bottom, I think I'm going to undo that. I think I had a setting that did not use my little boundary, so let's just show that boundary. And I'm going to go to this here. Yep, we need to use our area of interest, so we'll run that query again. So you can see this place, the 137 that were loaded. Now that looks a little better. You can see down the bottom I have 8 boundaries loaded. And if I zoom out a little, you can see the squares are colored either yellow or orange. And each one of those is a different kind of plan. The orange ones are sewer plans, the yellow ones are field checks. So this is where obviously this was printed out. So at any time I can come in later on now and get a punch list of plans that intersect that area. And then I can come in, of course, on the screen and load those. So I just go in and load the image. It says which one. Let's say this one here. And hit enter, and it'll go. It knows the path. It can load it, and now we can restore it as backdrop again. And so you'll see these values here were actually loaded, they're by the depths, and we've got 7.4, 454.74, and there's all calculated field check. So this was a project to load this. So that's paper. You can draw straight off the menu. And when I say if you do that, you can, you're essentially recreating CAD data, and you could be doing that just in your GIS product as well. Except for CAD really does offer a very, very rich drawing experience and very efficient. But if the plans came in as CAD data, the thing you could do in Mansus here is you can literally just go in and convert a whole bunch of line work or blocks to any kind of object using, and this is in the water application, and we have specific industry-specific applications for the various utilities. So if I was taking this set of lines and I said, okay, I'm going to use the actual CAD geometry for these lines, I could go in and do a quick select and select them all by layer or whatever, but I'm just, for now, I'll just pick a few. And I could go in and convert that. So I've taken that as CAD now and turned it into a database object. All that we've done is taken the default. So at that point, you could also go in and edit attributes. So we take this CAD data here that we just put in, and we can say, okay, let's edit the attributes on that. And let's say that actually was a 6-inch PVC pipe. Okay, it's a supply mains, and so we start adding. You could be doing this in your GIS, except that I've now converted that directly from CAD into here. Mansus deals with arcs, it deals with attributes and blocks, so that you can build these out, and then it also allows you to build structured networks. So very, very powerful set of tools, and really speeds up the ability to do that. Now there's a couple of things you have to bear in mind. The reason that this is, one of the reasons this is very powerful, is you want to keep data in the control of the people who use the data. So for engineers, you want to keep them using CAD. And so Mansus allows them to edit their own data. Every bit of data that I convert here into the database can be viewed and connected to through ESRI, for example. So what we're doing is you're changing who's responsible for editing the data, and that's really probably the biggest impact, because you don't then have to go to an engineer and say, oh, by the way, you're going to use CAD and GIS, and you're kind of sort of going to work between the two of them. Mostly, if you're using the Mansus product, you can continue to use CAD and build out your data, but in the meantime, you really are building GIS data with structured, connected networks that are traceable, drainable, all of that, and I'll show you that just in a minute. So inside of Mansus, there also is the MunConvert, because part of the problem is that a lot of the objects have more data, like in a block or something. So line work, you kind of pick out layers or whatever. But let's say I wanted to go and do water nodes. We could come in and look at the drawing. And so this is a tool for pulling in, if I go to assign, if there was object data, you could see these are all of the object data tables in this drawing. I could pick up for this particular node type feature category, and I could put that into that column in the database. I could also go in and look at if there was elevation, I could pick that up off of the object property. You see this is exposing all of the details within the CAD drawing. Okay, so if I looked at object dot, let's see, we got a block position Z, so that would probably be for the nodes. We would put that in as the elevation. So as I go in here, I can put things in. You can assign IDs. So if you don't have an actual number, you could assign that from a sequence, so from a database sequence. So we come in here, we put it in off of, say, we're doing water and nodes, so that would get the next available number. Any number of those things. So you can put in, and this is literally mapping. Here's the table in the database. Where am I getting that from the drawing? You save those profiles, and you hit OK, and you select your objects, and you put them into the database. And that's really how you can go from this, which is the CAD drawing, to this, and I'll show you the processed version of this data. So let's go to the CAD drawing. Actually, I'll stay there, pick an area, I'll set a window. You see this window? Let's look at that. I'll zoom to it, so we'll be in the same zoom state. So there's a blue box which you could probably hardly see there, and I'm going to go and look at that in this here, which is then a query back out of the database of the same GIS data. So let's zoom to that same position. So here's that same network, except now the line work is consistent. So if I select a pipe, it goes from node to node. Let's zoom in and show you that. So there's a hydrant over there, there's a valve over there, here's a pipe. And it goes from the hydrant to this valve. It has these 3 service connections on it. So if I click on that pipe, it's a 8-inch transmission mains, and actually let's put this to formatted values. Right, here we go. So it's, as an ID, it's 8-inch transmission mains, it's cast iron, it's start and end node, which is the number of the internal number of that valve and that hydrant. Start and end nodes are these 2. It's a potable water. We know that it's on zone 3, it's got low risk cross-country property. It was installed in 1962, and we started building out the modeling on it. In addition to that, using the data models in Mansus, there's 3 service connections on that pipe. You'll see they don't break the pipe. So there's a whole lot of specific things in these applications that are on the menus that you build out. So now we've gone from a CAD drawing to a structured drawing that has a whole lot of data in it. All right, let me go back to the PowerPoint quickly. So that's what this picture shows. You can go from CAD to GIS. Let's look at this example. Here's a campus. These are all, there were like 16 different utilities, gas, underground tunnels, steam, everything else. And you can select on something, and I showed you that you get these attributes and pick lists for editing and updating to keep your data integrity there. So that's the first part, which is really just using the Mansus CAD GIS thing. So I'm going to just I'm going to move on to the second part of the presentation, which is ACDC, but before we do that, I've just opened the poll to ask you, where does most of your new data in your organization, new data, where does that come from? Okay, I'm going to give you just a few seconds to answer that, and then I'm just going to talk about the second part of this. All right, so far we've got fairly good response, and we've got, I'll let it go for another 5-10 seconds. Looks like most folks just about voted. All right, so where does the new data come from? I'll read it out. We've got, I've closed the poll. We've got 70% of new data comes from CAD. And the percentages aren't going to add up, by the way. 30% GIS, 30% GPS, 20% paper, and 20% LiDAR. So by far and away, the majority is still coming from CAD. So let's talk about organizations where they have, so thanks for doing the poll. Let's talk about this ACDC product. The first part I've talked about, Mansus and CAD and paper, was all about if you want CAD folks to do the data capture themselves. And I actually recommend that because it keeps the data where it needs to be. It gives people who have the right background training for that particular data, particularly if it's utility kind of asset information. It keeps that in the right place. So first part of this presentation was all about using Mansus to edit that yourself. ACDC, on the other hand, is a slightly different way of getting CAD data into your GIS. This requires actually very little use of actual CAD folks. It is more an automated process. So ACDC is the automating the validation and loading of data from submittals of as-built directly into your GIS. So let's talk about that a little bit. So it's also bridging that gap between CAD and GIS. So what we're trying to do is get your data into your corporate data stores so that they standardize and fit in. They've got the right attributes, they got the right numbering, they've been checked, they make that easy. And what we want to do is automate that. So what ACDC does is it allows people who are doing CAD plan sets to check those sets before they even submit. Okay, so yes, if it's internal, they can do it. If it's external, they can do it. The way we do that is we use two things. We have a configurator and a validator. The configurator, the CAD person creating their new plans doesn't know anything about the configurator, except that this is where we as the GIS folks set up. That could be you could be doing it, or us, we can help you with that. But you set up a template, a CAD template, and you give it back to these folks. And in the template, it sets all of the block names, the attributes, the scales, the line types, the layers. We set up that template up, and obviously we have a whole lot of those ready to go. And also the rules to check. So configurator is kind of a two-way street. It's what you give people to use. It also defines what we're going to check and how that gets mapped into your data. So the configurator contains a template, rules, and data mapping. And by data mapping, it's where it goes when it goes through. Rules is what to check. Things like you can't have a pipe with nothing on the end. You can't have a manhole not connected to something. You can't have an ADA ramp unless it touches a curb. You can go to any length. You can't put something on this. You can only put text on this layer. Things like that. Or the line style has to be, this when it's on that layer. And we set all of that up. And the reason for that is to make it such that when data comes in, it's standardized, it's very easy to automate and validate it. In the validation process, over here, in the validator, I'll talk about how we deliver it. We deliver it either on the desktop as a client application or on the web as a portal. So people can literally just submit drawings to the web and they pass or fail. All we're checking when you run the validation is what you set up in Configurator. Configurator can deal with geometry. It can deal with project-wide stuff like what's the project number and assign that onto every asset. It can deal with all of the CAD stuff like layers, block names, scales, line styles. It also deals with geometry, snapping. Is it even in the boundary of where the project's supposed to be, the lat long or XY coordinates? So you can set all of that up. Very powerful stuff. So you run the validator, the drawing passes or fails. Remember, people are doing this before they even submit. So now we've actually moved the checking outside the building, conceptually anyway, so the people checking this before they submit. And that also helps you, because if you get a drawing that has already passed the validation, you know that it's subscribed to all of those standards. It still needs engineering checking for, volumes, sizes, stresses, or whatever else it is. But you know that stuff's on the right layers, you've got the blocks, anything that's mandatory, like if you want depth of manholes or you need type of hydrant as an attribute and it's mandatory on an object, then yeah, we can check that. So if it fails, they get a return drawing, and in the drawing we actually put error markers and we give them a list of what's wrong and error markers where they are in the drawing. People can go fix it. When we create this template, we create it with the blocks in it, with the layers and everything. We give them the template drawing, and they can then literally use the existing templates to build it out. And the template will run on AutoCAD LT, so we've gone for lowest common denominator. So mom and pops actually love this because it means they can create data that a big company can also create because they're using the same standard. So it kind of levels the playing field. If all of that passes, you can push another button and directly load the data using the mapping into whatever system you want, and we'll simultaneously do CMMSs and GISs or SAP or whatever it is, Maximo or anything like that. So to do the configuration, we check the location. We literally go through where every object in the drawing needs to be put into your destination database. So you take a fair amount of time defining it, but after that you then can push the button and load stuff, which is a whole lot better than rethinking it through every single time you get a submittal or drawing it up or having various people do data capture. We also define exactly where to find the attribute information. Is it in the layer name? Is it on an attribute? What's the name of the attribute? What are the values? Is it a date field? Is it a numeric? Do you check? We check for all of those things. The required data format and also the geometric requirements. So we can do snapping. We can check whether something is on the end point, the midpoint, or if it's dangling inside of a polygon or whatever. So we build that all out. So the validator, it has its own little icon. You actually set up and run the rules inside of ACDC's validator, and that's in AutoCAD. You define the rules in there. The rules themselves are stored in a rules database. That can be in SQL Server, Oracle, anything like that. And what we didn't do is we allow, through the validator, we actually validate and then extract the attributes. And so the validation allows you then to also load that data directly into your system. So we do geometry, attributes, and snapping, any of those. We write errors out. So let's show you a few pictures. Here's a drawing drawn with the template. So the template would have like a block for a stormwater manhole, and it would have these attributes in it, and you'd fill it out. This one looks like metric, probably comes from Australia. And it'll have in there. So if you look at the properties, so when we create the template, we would actually create a block with these things for you, and you'd need to go and fill them out. So you drag and drop the block, place it, and then put the text set to which ones display, what needs to be displayed, and then people could put in data. And some of these are mandatory and some are not. So that's drawing it. Simple. People are doing that right now at the moment anyway. All we're saying is, hey, here's a template and here's our standards. So all that's stored in there. We also deal with line and polygon data, and for line data we put a block on the midpoint of the line or in the center point of the polygon and associate the attributes with that. And then when you do validation, we pick up those attributes and assign them on the line or the polygon, and then you'll see them just like I was showing you in Mansus a while ago. Here, for example, is diameter and length, and you can see that the letter I there has been put in, and so that will come up. That's a numeric column cannot have that, so it's going to pop up as an error. So here's how you'd see it as an error. A circle would be drawn in the drawing on an error layer, and the user would actually get that circle block would have the name of the column and what was wrong. And they literally can zoom to each one of these and go fix it. So when you get a drawing back with errors in it, that's what you get. You also get a listing of those errors, so you can literally punch list and go through them. So what we've done is change the old process from taking various CAD standards and templates, stuff that's drawn, by the engineers. They then get delivered to by the consultants engineers to your organization. You then have a plan check approval process, and at some point when it's gone through that, you get as constructed submittals. Hopefully you have it in place where they actually submit. Now that the plans have been approved, we've gone and done the construction, we do a second round and we get these submittals. Usually this is paper. You can ask for that in CAD, especially as you've given them the template. So there's sort of the carrot and the whip here, because you can say, look, we'll give you the template, we'll give you automated tools for how to check, and that means we'll do the approval faster, or we won't charge you to have to capture the data when we get it, because if we get paper data, we actually as an organization are paying for the capture of that. So you can use that as one of those little carrots to say, if you use these standards, we're not going to add a premium on for having to capture the data. Not all organizations do that, but in essence it is costing them. At that point you can then put this asset information into your GIS and put it in there, but you would have had human intervention here to go and scratch through these plans. What we do is we change it. We follow the same process, we just made it way more automated in the middle. We give them a template, so people for any given project have to use a specific template. So if you go out to bid, you say, here's the template, it's available there, everybody can look at it, there's the standards. Has all the rules defined. So anybody drawing will do that. Or if you have standard development plans, you can keep those there. So those get drawn just like they would any other way. And then people pre-validate these plans before they even put it to the plan check approval. And the plan check approval, once it's passed here, we actually can notify you that the plans are ready, and you can go put that into your approval process. And then once they get back to their submittals, you can insist that a CAD drawing if you really wanted it to go all the way, and I know it takes time and people, you've got to kind of work on it, but 5-10 years from now, we should be able to take a plan, push a button, get the data, or check it, and that's what this thing does. So the as constructed submittal, if you get an updated drawing file here, you could just as well validate that as well and directly, automatically load it into the system. So what we've done is that whole validation piece, we've also put that on the web. So there's the ACDC portal. If you go to www.asconstructed.com, we'll give you an account, your organization or that particular project, and then you manage that and you set the standards, and then you can have consultants or internal folks upload and check without you doing anything. The other thing is the validator and configurator run on the desktop. So the validator, you can just as well also use those same rules, go into AutoCAD and run it and check against your corporate thing. And when you want to load the data into your system, you will need on the desktop to have it connected to your corporate systems, and then we will literally insert data into tables. Normally in the GIS world, they're put into temporary tables, and then somebody matches or ties that in together with the existing GIS data, but it's already data that's in there and it's already been checked for attributes, so it's a whole lot different than having to capture it from scratch. So the portal itself allows people to pre-check. It gives you a very quick turnaround and gives you a independent sign-off. The benefits to the organization is you're only checking data on drawings. You're not checking whether they've got layers and line styles and stuff like that. You actually are doing the intelligent part of checking as opposed to the menial part of checking. Okay, so that's kind of the portal. I can just, some customer comments, ACDC developers. Get that audio, hopefully you can hear me again. All right, and I'm just finishing up here. ACDC really has changed the way AutoCAD data is used. There's no double handling of data, and these guys really have reduced something that took from 5 days, have reduced it down to 20 minutes. They've redeployed staff into doing productive tasks rather than the menial checking of these plans just for standards, and really been able to catch up on their backlog. Now they've got an up-to-date asset database, just no negative feedback. The staff is running way more efficiently. Here's a screenshot of the asconstructor.com. If you have a username, you can log in. If you're interested, if you go to asconstructor.com, there are a couple of, there's a customer story and an overview, little 5-minute presentation there, and you can read about it. If you log in, this is what it looks like. And here's literally, once you log in as your user, you've got certain projects you can submit drawings to, and they either pass, fail, or they have errors, and you can then get that download back. So that's literally all it is. You configure it, we set up an account, and that people can then log in and go to it. So that's ACDC. So that's part 2, and we can wrap it up. I'm going to take a last poll here. Where does most of your data changes? Where does that come from? So last poll, where do most of the changes to your data, where do those come from? I'll just let it run a few seconds, and then we can leave it at that. All right, interesting. We've got I'll go what, 10 more seconds. All right, so I'm going to let it stop at that point. 43% of data changes are coming from CAD, so still far away the majority. 29% from GPS, 14% from GIS, and 14% from paper. So what I've talked about today really remains a key part of the organization's time and effort on data, both the new stuff and the changes. Let's finish up. So ACDC really helps you optimize your processing. It gives you flexibility because you can define the standards yourself, or you can use existing standards. It allows you to validate sort of across the board equally. It really allows staff making decisions to get better data, to use that. It really has a proven return on investment. And aside from the initial training, after that, there's not a lot more training or support required. So to finish up, just to kind of show, I started out with CAD and paper. Let's just finish up with GIS stuff. Here's then a complete attributed network. You can see a listing of diameters, materials, start nodes, end nodes. If you take that data set, you can push that into the web. Here's that same data I was editing on, and actually it's now been integrated with GIS stuff. So you can edit, view, and query, like here's the water consumption for that particular customer and their last 3 months. And this one where consumption is 4 times the average of the last 3 months, we've been highlighted those ones in yellow. So we've gone all the way from where the pipes are right to billing and tied that in. Here's something like here, if this pipe breaks, which valves do you need to shut off? 3 valves, and which customers get impacted. So that's using that network and building it up. The same data I was editing on just a minute ago. Here's a report, for example, of pipe type by decade and the number of miles. And yes, there's still 9% unknown material and 15% unknown age, but building that out using the GIS. This particular customer 2 years ago, there's just no ways that they've been able to do this. And we can look at things like some pipes like asbestos cement. Well, turn of the century, they really didn't have them. So that's probably a data error, okay? It was put in a certain time period. Things like, you know, what data has been captured over what time period, things like that. You can really build it out. Here's a campus, for example. If you look at this area down here, you can all the utilities, compressed air, chilled water, electrical, underground, grounds and gardens, construction improvement projects, snow cleaning, and you can start. If you turn on, there's all the utilities turn on, just that middle piece. All of that is now GIS. If you zoom in on something, you've got all of this information. That was all CAD. If you look at these ones, this is grounds and gardens. So here we've got every ground panel, every tree. Here's project areas, capital improvements. This here is coming from the work order management system that's got capital improvements on it. If you click on that, here's the construction start, end, contact name. Here's the same data. You see these little spots? Those little dots are the utilities underground. If I back off that image, you can actually see through it. So looking at that manhole and that tree, we can get attributes. So this is a live view of the data that was all CAD. Gone into GIS. If I back off the image, here's that same data underground. You're looking through the image, same buildings. If I go zoom and underneath, I didn't do the 3D thing. I'm just taking screenshots of it, but it's live, move around on it. That's really where we're at, so trying to tie it together. So thank you very much. Any questions? We're happy to take those. And appreciate your time. Just to, running through that CAD to GIS. If you want to, find out more on how that works, or other, case studies or anything specific, let us know.
Yeah, and actually to follow up on that, Colin, at gismadesimple.com, there's actually a couple of links to some useful videos that may be interesting, and there's also a calendar link there where you can schedule time with Colin directly to discuss your situation in detail. Colin's actually very generous with his time, and his expertise has helped a lot of organizations, whether they were open spatial customers or not. And we frequently hear people saying that they wish that they had had conversations with him and heard his perspective prior to some of the internal business decisions that they've made. So that's an opportunity for you with no obligation to just get a perspective on your own situation and kind of discuss some of the strategies that you're considering internally. And that's gismadesimple.com.